Jay. Welcome to another episode of Aptos development. So here I'm on Aptos Learn, which is a website we make for people to learn how to build on Aptos. So here it has a bunch of templates and tutorial. And in today's video, we're gonna learn about what is dispatchable fungible asset on Aptos. So this video will have three parts. The first part is an introduction to the DFA, which stands for dispatchable fungible asset, and we're gonna talk about what it is at a high level, compare it with the similar standard on other chain, and also briefly talk about the use case. And the second part is that we're gonna look at actual implementation of a DFA contract. And the third part is we're gonna talk about how this DFA contract can interact with the other contract on Aptos. So you also get to learn how to do cross contract call on Aptos. So let's go to the first part. So the first part is like, what is DFA? So to explain DFA, we first need to understand what is fungible asset standard is on Aptos. So if you are familiar with EVM or Solana, or basically any other chain, there's usually a token standard. For EVM, it's ERC20. For Solana, that's the token program. For Aptos, we call it fungible asset. And so Aptos in this case is kind of similar to Solana, where all the tokens are minted from the same contract. For Solana, all the tokens are minted from the token program, like there's a canonical token program. And on Aptos, all fungible assets are minted by the 0x1 fungible assets module. So dispatchable means when the fungible asset gets transferred, the developer can define custom behavior in the transfer function. So this is useful when you want to add more utility to the token. For example, you may want to add a allow list or block list if this is a regulated token. For example, for some stablecoin, you might want to be able to block certain address or only allow certain address to send or receive this token. And also some other use case is like the creator get to collect a tax whenever the token is transferred. So this is similar to the creator fee in NFT, but enforced at the token level, because the the logic in the transfer function gets executed as part of the native token transfer. So it does not rely on external contract, or for example, it doesn't rely on the DEX contract or wallet to enforce this. It just gets enforced as a framework level. So which can be super convenient. So for EVM, if you want to implement a transfer hook or like this dispatchable feature, you would just override the transfer function, because for ERC20 it's enforced by interface, not by some specific contract. But on Solana, it's if you want to implement the transfer hook, you need to use their new token program called Token 2022, which is a different contract from the original token program. And that one allows you to add like different feature or like write custom code in the transfer function. And for Aptos, we didn't introduce a new fungible asset module. Instead, we add like a new module called dispatchable fungible asset, which is like an extension of the original fungible assets module. So if you want to register like or implement custom hook, it's like super straightforward, and it doesn't break the composability with the existing fungible asset module, or it doesn't. So like for new token launched with dispatchable feature, it will just work automatically with all the existing token infra, for example, indexer or like the DEX. It's not like Solana that will like all the infra need to adopt this new token program. So that's what DFA is at a high level. By the way, we also have a blog. We'll like talk about the 101 of DFA. It should be linked under the Aptos Foundation blog. You can also check that out. So now we understand what DFA is. Let's jump into the code and see how DFA is actually implemented. So here we actually have the step-by-step breakdown of how the DFA contract is implemented. But now let's just jump straight to the code. So again, as always, when we look at the Mu contract, we first started with this mu.toml file, which is like the management file, like the package.json for Mu contract. So here we can see we define two addresses. The first one is text FA. The second one is TFA recipient. Because what this contract does is like when this contract is deployed, it will create token. We call it TFA. It stands for text fungible asset, and we're gonna mint the whole supply to this recipient. So let's look at the code. So this contract implements a feature called buy sell tax. That means whenever the token is traded from a particular DEX pool, the creator of the token gets to collect a tax from the amount of token that's traded. So here we have let's first look at the data structure. So data structure is pretty simple. We just maintain a set of registered DEX pool, and because each DEX pool is actually an object or like a fungible asset itself, so we use the object with metadata type here to represent the pool address. And then we define these two events. So this will get emitted when there's a buy tax collected or the sell tax get collected. So now let's look at the init module part. So this function will execute when this contract is deployed. So here we just create a token like a normal fungible asset, and then we're gonna mint the whole supply to the TFA recipient address. So until this part, this is also the same as a normal fungible asset. And this is where it gets interesting. So here you can see we are defining the custom withdraw function and the custom deposit function. And custom withdraw and custom deposit are implemented like down below, and we'll get to that later. So what it does here is like we are registering the custom deposit and custom withdraw function. Alternatively, you can also optionally you can also register a derived balance function. If we click into this, you can see we can override how the balance is calculated as well. But in this case, we don't need to override that part. We just need to override the deposit and withdraw. So now once we register these two custom behavior, whenever there's a token transfer happen, these two function will be executed. So it will not call the regular withdraw or deposit. And another thing to keep in mind is like you can only register the custom behavior at the creation time of the fungible asset, because you need to have the constructor ref in order to register this custom behavior. And constructor ref is only available at the creation time. After the creation time, once a token is created, you can no longer retrieve this constructor ref. That means you can no longer register any custom withdraw or custom deposit function here. So I think the what we recommend people to do these days is like you probably always want to register the custom withdrawal and custom deposit at creation time, even if you don't need to, because you can always have, if you do this, you can always have the option to upgrade the contract later and add your custom logic to the withdrawal or deposit. So now let's look at the how the custom withdrawal and custom deposit actually work. So the interface, like the function signature, is same as the standard withdrawal and deposit. So it's just the logic inside of it is augmented. So what we do here is like we will get the config, and we're gonna check if the owner of the store is in the registered DEX pool. So if it's not part of the registered DEX pool, it means this is a normal transfer. Like it's not interacting, it's not a buy-sell action against the pool. So we just call the standard, like the default withdrawal function, and this will behave the same as a standard withdrawal. But if in other case, if this withdrawal is indeed withdrawing from the DEX pool, then that means the user is trying to buy the TFA from the pool, and we're gonna implement we're gonna collect the tax in this case. So, and we also do a little math check here to make sure the tax amount is not zero. Here, like I guess in production, you probably want to make it more sophisticated, because right now the user can probably bypass the tax by always just buying a very little amount to make sure like the tax is zero. So basically evade the tax, because right now the tax rate is 10%. So if the user only buy let's say less than 10 token, then the tax amount is essentially zero, because it gets rounded to zero. So in that case, the tax is cannot be collected. So now let's assume like the tax can be collected. So we're gonna deduct the tax amount from the original amount and to get the amount that user actually would get, and we're gonna send the user amount to the user, and also send the tax amount to the creator, right? The creator address is calculated from actually we're not sending directly to the creator, we're sending the fungible asset store of the creator. This is just some detail of Aptos. So, but essentially we send the tax part to the creator, and in the end we're gonna emit by tax collected event, and we return the user assets. And for the deposit part, it's very similar. It just this case we check if it's user is selling the TFA to the pool, and if it's indeed user selling the TFA, then we're gonna first deduct the tax amount and send the rest of the TFA to the pool. So user would actually get less token on the other side. So this is what the contract looks like. You can see it's pretty straightforward. We basically just overwrite the deposit function and the withdraw function to make it check if the user is interacting with a DEX pool. If it is, we're gonna collect the tax. If not, we're gonna execute the default behavior. By the way, the complete source code of the contract is located in move by example repo under GitHub. So under this repo called fungible asset with buy sell tags. Okay, so for the last part, let's look at how this actually gets this TFA gets integrated with the DEX. Because remember, like we need to register some DEX pool in order to collect the tags. So let's take a look at how we actually create some DEX pool in the contract. So here we are using Move script to create a pool. And let's look at this, how to create a Hyperion pool. So basically we first need to mock the Hyperion contract interface. This is we have to do this when the contract source code is not public, because we have to have some mock contract interface in order to pass the type check of move. This might be one of the slightly annoying part of building with move. But we have a tool for that to generate the mock interface, so it's not that bad, I guess. So here you can see we are creating a pool with TFA and APT, and the initial APT liquidity. These are all in the smallest decimal. APT has 8 decimals, so this is very little amount. And TFA, I think it has 6 decimals, so this is just 5 TFA. And we also need to do some conversion. Let's not talk about this part to further confuse people. Basically, we just call the create liquidity function from Hyperion and pass the APT address and the TFA address, and then these are other parameter setting the fee rate and the range, because Hyperion is a concentrated liquidity pool, so you need to pass a bit more parameters. So once we executed this move script, the pool will be set up with initial liquidity. Then we need to register the pool in our TFA contract. So we just call register pool function here. That will add the pool address to this set. And once we registered, we can do a swap to see if the tax is indeed collected. So here we are swapping from TFA to APT. So we're essentially selling the TFA. So if we do execute this transaction on the Explorer, there's an Events tab. You should be able to see the sell tax get collected event. And I think that's it. That's everything. And hope you enjoy this video. And if you have more questions about the dispatchable fungible asset standard or anything related to building on Aptos, you can open a thread on this GitHub discussion, or you can also DM me on Twitter. So that's it. I'll see you in the next video.